Chemistry time. Hello there, and welcome back to Chemist Tea Time. Today we are going to be discussing one of the most important topics in chemistry, the mole. And no, we aren't talking about those furry little critters that burrow underground. In chemistry, the mole is actually a number. Imagine walking into a bakery and ordering donuts. If you're ordering a lot of donuts, you may order a dozen of them. When we say a dozen, we know that this means 12 donuts. But we can also use the word dozen to refer to 12 of anything, whether it's a bagel, cat, or a cup of tea. No matter what we use the word dozen to describe, we know that it will always mean 12 of that item. We can also use half dozen or 2 dozen to describe fractions or multiples of 12. Well, the mole works in exactly the same way. The mole represents a specific number of whatever you are referring to. This number is referred to as Avogadro's number, named after the researcher who coined the term, and is 6.02 times 10 to the 23rd. Now that's a lot of donuts. Also, just like the term dozen, we can use fractions or multiples of the mole to refer to a fewer or greater number of that item. Now, usually when we use the mole quantity, we are referring to small particles such as atoms or molecules. So a mole of helium atoms would be equal to 6.02 times 10 to the 23rd atoms of helium. This brings us to the importance of using moles as a quantity of atoms. It was determined experimentally that the mass of a mole of atoms for a particular element is equal to that element's average atomic mass in grams. We call this mass the molar mass of that particular element. For example, if we look at carbon, it has an average atomic mass of 12.01 AMU, so a mole of carbon atoms would have a molar mass of 12.01 grams per mole. Phosphorus has an average atomic mass of 30.97 AMU, so the molar mass of phosphorus would be 30.97 grams per mole. It is important to note that in both of these examples, we still have 6.02 times 10 to the 23 atoms in each mole of element, even though the mass is different because the mole only refers to the quantity of atoms. Another important aspect of the mole is that it allows us to easily convert between the mass of an element and the number of atoms. I want to point out and stress that the majority of calculations that we do in chemistry are a series of conversion factors. Just as you would convert 4 feet to inches, you would multiply by the following conversion factor to convert to inches. We will be using the same logic. If we wanted to determine the number of atoms in 8.31 grams of aluminum, we can use the molar mass of aluminum as a conversion factor, which is 26.98 grams per mole. We also know that there are 6.02 times 10 to the 23 atoms of aluminum per mole. Keep in mind to always cancel out your units. When we multiply through the expression, we can calculate that 8.31 grams of aluminum contains 1.86 times 10 to the 23rd atoms of aluminum. We can also use these conversion factors to determine the mass of a specific number of atoms of an element. In this way, the number of the moles of an element become an important intermediate that we can use to determine different properties, and we will continue to use the mole as a quantity throughout our discussions. Hopefully today's discussion has been helpful in understanding the mole as a quantity in ways we can use it to convert between mass and the number of particles. Have a wonderful day, and thank you for joining me. Chemistry time.